please. Where are you? Oh, you're here. You're here. I have now this planchette Janis was telling about. I cannot see where I am without coordinates. Thank you. Thank you very much.
Thank you. Good afternoon. So I'm here on overtime between you and coffee, so I try to be quick and be patient. First, maybe a few words about myself. I have been working in the software industry for 37 years, done all the jobs there is to do in the software industry, both technical and commercial. So I have a pretty long experience. I have done both geospatial infrastructure and building BIM things. As you see, my title is BIM Ambassador for Trimble, so my job is to advocate and promote BIM in general and Open BIM in particular. And I'm also Trimble's standardization expert, so I represent Trimble in a bunch of standards organizations, Building Smart, OGC, ISO, CEN, ILA, and some others. So I work both with promoting and advocating open standard and with developing them. And that's my sole job within Trimble. So first, a bit of history of information, because information is going to be my theme, what I'm going to talk about. And this is kind of history of how information has been modeled and handled in the construction industry. And this is a pretty sad story if we look at it. If we look, we have been making buildings for about 10,000 years. And we only have a few milestones in how information has been handled, how information handling has changed in the construction industry. So originally, it was mostly empirical, making some physical models. Then came hand-drawn painting type of drawings, which were drawn manually, so they were not possible to distribute. And the first big milestone was the invention of the blueprint machine about 100 years ago, when we started to get these documents and drawings which could be proliferated throughout the project and everybody could access them and have them. And since then, we haven't had a big change, because CAD was not a big change when CAD came. CAD only changed how we produce the information, but it did nothing to how we consume the information, how we use the information. So we still use the information in the same way that we have been using in the last 100 years, mostly. And that's not being now changed by BIM, because with BIM we are going back to building virtually, building models. So now we are on the verge of the next big change from the blueprint machine. So as I'm the BIM ambassador, so I get to tell you what BIM is. We have, firstly, there is no real consensus of what BIM is. So every person has his own perception and own impression of what BIM is. And most people think that it's BIM software. If you use some piece of software, you are doing BIM. And others that you often hear, process, model, populated database, and others. But my favorite is that BIM is a technology, nothing more, nothing less. It is one technology that we will use in the construction industry. And what technology is BIM then? I have a very pragmatic and practical view on BIM. To me, BIM is just the most kind of gist, the core of BIM is that we go from human-readable documents to machine-readable data. And I'm very happy that Rainer talked about machine-readable data here earlier, because usually I'm the lonely wolf talking about machine-readable data, but that's very important. That's what's going to make the big change. Because with documents, however we produce them, drawing by hand, blueprint, on the screen documents, it's still all human-readable. So a human always has to read the document and act upon it. Whereas machine-readable data, we can feed directly to software, and the software can understand it and act upon it spontaneously and automatically. So my executive summary of BIM is automating reception and consumption of data, which has been the same for 100 years. And that's a big deal, because that means that we can really use software when we consume the information. And then what we do is that we go from documents, which is just spaghetti data, human readable, to semantic structured data, as it's called. So we have an agreed structure for the data. So we have objects where we model, and we have overlapping objects, we have architectural objects, physical objects, constraints, and abstract objects, and also objects that define the process, how we are going to build. So in BIM, we use the objects modeling structure for information. And then a few words about OpenBIM. What does OpenBIM mean? It means that the data is not tied to any specific tool or software or vendor. And that means in practice that we use open standard data formats which are accessible to everybody. Everybody can use them. IFC has been mentioned here a few times. That's definitely the most important structure in construction. But we also have CityGML, which is more for the city level development, KML and other standards. And we use those to communicate between the different parties and processes in the construction industry. Then if we look a bit on BIM adoption, how it's really used. So if we look at this BIM, I call this legacy BIM, traditional BIM, we create models, we create the semantic data, but we use it to produce documents, and we communicate with those documents. That's the legacy BIM, and that's beyond this technology chasm in every market, I would say. There is no going back to just drawings. But then if we look at OpenBIM, that we actually give out the semantic data to the other parties in the construction industry, that's as clear still ahead of the chasm. And my job is to gather the momentum that we can jump over this chasm to make this an everyday practice to share and use the semantic data in the process. And why do we need this semantic data then? The construction industry has been really bad in using information technology and technology in general. You have probably all seen these curves about construction industry productivity. Every other industry has been going up 100% and construction industry down. And the reason is that construction industry has not used technology and IT as to its potential. And the reason to that is that the construction industry is so fragmented. There is no process owner who can mandate that now we in this project we use these technologies. Nobody has that power in a construction project because there is no owner of the whole project. The owner changes many times during the project, and that has led to the situation. But OpenBIM promises to be the solution to this because we are not tied to any specific tool or technology. We can use whatever we like as long as we use those open standards which can be used by everybody. And my prediction is that the killer app for semantic data to have real structured data will be augmented reality. So using that, but there are other uses as well. You can use it directly to control machinery, robots, whatever. But this is very clear that having these touch devices, this is just an intermediate step. In the future, we will be using wearables. And especially in construction, it's quite easy because we have helmets anyway. So embedded the technology in the helmet is going to be very easy. So that's my prediction, that this will drive the change. And Trimble has been very active in this field, so we have been together with Microsoft developing this HoloLens. I heard an explanation of this, that it's outrageously amazing. And having tried it, this is me trying it on, and I would agree, this is amazingly incredible what you can do with this, and when you combine the real world and virtual world, and that's why it's called mixed reality. Then, of course, robots are coming. That's a very important use for the semantic data. Of course, we are very strong in steel, the whole Tekla, coming from Trimble. I'm from the Tekla part of Trimble. So this is where we are today in steel. We can deliver flat pack steel delivery almost automatically. So we get the information from the model, control the machinery at the shop floor, which makes all of these parts more or less automatically without human intervention. In a big factory making tens of thousands of tons steel a year, you might have 2 or 3 workers in the factory. It can be almost totally automatic. The workers are just controlling the machinery and they produce this. But today still, when we go to the assembly, when we weld those together and make the actual steel parts and steel structures, that's mostly manual work. So that factory would have 300 people in the section of the factory doing the assembly. But that's about to change, because now the next step is that we will also automate the welding and the assembly of the structures and using robots. And this is a very interesting picture in itself, because this predicts the future, that everything is becoming commoditized. Traditionally, the steel machinery which makes the parts is very special purpose machinery made by special companies, very complex, expensive machinery. But that's about to change, because now you can, for cheap money, buy a standard industrial robot, you bolt it onto some kind of pedestal like this, and then you write software. So this is one part of the general development, that everything is becoming software. The hardware is totally, you can buy a processor for a few dollars which does almost the work of the most expensive, so everything is leveling out in the hardware, and on the machinery and mechanical sides, that's industrial robots, which are very precise, very durable, very reliable today, and the only thing to control them and use them heavily in the construction is writing software. And that's going to also change the prefabrication, because these machines are much cheaper than the previous generation of machines. They are also smaller, so they can be put on site. So you don't only have off-site prefabrication, you can also have on-site prefabrication, which can in some cases be much more beneficial than transporting, like making big rebar cases. That's very hard to transport. It's much easier to have a robot that builds them on site, and then you just lift them to place with the crane. So this gives a huge potential to making construction more effective and improving the quality of construction, because the more it's automated, usually the better quality you have. That's also a promise of BIM, of course. To do this, to do the automation, you need to design the building fully. And that hasn't been the case. Traditionally, you have had only GA drawings and type details, so you haven't solved the detail at every instance of the detail. With BIM, you can do so now, and you have to be able to use these. But BIM also gives you the productivity in the design stage, that you can actually fully design a building down to the last detail, which means that you can prefabricate and can use technology. That's a prerequisite also, apart from the information, that the kind of design, and that leads to some changes in competence, because competencies which you today have only at the site, you will need to have in the design and planning phase also of the construction. So that BIM is going to bring about quite fundamental changes, but we are still very early. This is very early days still. It's going to change. And also the focus in BIM is changing to the consumption of information. So software dealing with consumption, how we use the information, is going to be the bulk of software developed for BIM in the future. So this is my message. Nothing, there should be. Oh, oops, one slide missing. Okay, but the one slide was a crossover drawings and a crossover tape measures. So no more drawings and no more tape measures on site is my message in the future. Okay, thank you.